Good morning, ladies and gentlemen. Do this now. In your notes. Go.
Do that information mining thing.
Yeah. Okay, let's do it. A ball starting from rest accelerates down a track in 2.5 seconds. Its final velocity is that. What is its acceleration? Show all work. And let me start with my equation for acceleration. Okay. And then let's see, information mining. We start from rest. That means my beginning velocity is going to be 0, right?
Yep.
Okay. Accelerates down a track in 2.5 seconds. If its final velocity, isn't it nice just tells us what it is 6.2 meters per second. What is its acceleration? We don't have to solve for anything. Sweet. Okay, so final velocity was 6.2 minus 0. It's like it's not even there. Time is 2.5 seconds. Let's go ahead and plug this in. 6.2 divided by 2.5, and I get 2.48. 2.48 meters per second, or per seconds squared.
How'd you guys do?
Hopefully you got it.
Yeah.
Okay. The velocity versus time graphs. Velocity versus time graphs. The slope is the acceleration. The area under the line equals the displacement. Okay. Let's take those two things and do something with it. Okay. Oh, too far.
Oh, that's good.
Maybe that was a little too far. Okay. All right. So we said the slope is the acceleration.
What kind of graph is this?
Good question. Velocity versus time.
Sweet.
So our slope is our acceleration, and we know that acceleration is v final minus v initial over t. Remember it, learn it. Okay. How many slopes do we have here? One here. Second one there. Can we calculate the slopes here?
Yeah.
Okay. So for our first one,
They might be able to guess this one.
you might be able to guess it.
You'd better be able
What
to
do you
guess.
think it is? Okay, so our final is going to be 4 meters per second minus initial is 4 meters per second.
Were you right? And how much time?
2 seconds. Now to do this math is silly because the top is 0. 0 divided by anything is
0.
0. So 0 meters per second squared. Okay.
It's a horizontal line, so
Oh,
that's appropriate.
Yeah, hopefully you guessed that right. Second one. Here we go. Velocity final is 0 meters per second minus 4 meters per second. And how much time was this? 2 seconds again. So I have a negative 4 divided by 2. That should be negative 2 meters per second. Negative? What does that mean?
It means this line's going down.
Yeah, okay.
Means it's slowing down.
Okay, it's negatively accelerating, it's slowing down. Kind of like when you're in your car and you put the brakes on.
What else can you get out of a velocity versus time graph?
We can get something else. Let's talk about the area under the curve of a velocity versus time graph is the displacement. So let's take a look at this curve right here. What shape is this?
That looked like a square, I'd say. It looked like kind of square.
So we can do base times height, right? So the area, base times height. Base is 1, 2.
Seconds.
Seconds, thank you, sir. Times 4 tall, right?
Yeah.
So 4 times 2 is
That's meters per second.
8. Oh, thank you, sir. Getting ahead of myself. Meters per second, which is perfect because then we get, oh yeah, good. Cancel, cancel. I'm like, what are we looking for here? Displacement, right? Meters.
So in the first 2 seconds, it goes 8 meters. Because it's going 4 meters per second.
Yeah.
And in 2 seconds, that's,
Covers 8 meters.
I like it.
Okay, for my next trick. Okay, what shape is this?
It's got 3 angles. What do you call those?
Triangle. Okay, so area of this is 1/2 base times height. Okay, so again, 2 seconds.
1/2 of that.
Times, oh, too excited. 1/2 times base times, oh, and then my height is 4 still. 4 meters per second. Cancel, cancel. Now this makes sense. It's 4. It's half the same, right?
Yeah.
Okay, because it's just cut in half. Okay.
So what would be the total displacement for the first 4 seconds?
Add these two up. 8, 9, 10, 11, 12 meters.
Boom!
So that means that in 4 seconds, if we go 4 seconds, we go 4 meters. Well, in 4 seconds, we've gone 12 meters.
Yep.
Okay. All right. Moving right along here.
Uh-oh, another do now.
Uh-oh. This one's going crazy.
What should the kids do now?
Okay, pause the video. In your notes, can you find where we did this before?
They did it before, right?
You've done it before.
What kind of stuff did they do when they did that?
It was called the roll the ball in the track lab. It was with the track and the table.
The motion diagrams and the equations.
Okay, find it. Find it in your notes. Okay. Now that you found it in your notes, make sure you tried first. Attempt the problem. Okay, now that you're done with that, let's see how you did. Do now. What is the speed on the table? Let me draw this real quick. So something like, ugh. Straight line is more. Okay, track table. And this is where the ball is accelerating, right?
Yep.
And this is where it's constant.
Yep.
Okay, what do I have here? So it says on the table, I'll write these over here. On the time for the table was 0.74 seconds. And then it says the distance of the table was 1.2, right?
Yeah.
So what was the speed on the table?
What's that equation for speed? It's
Speed is d over t.
Oh, that's right. That's right. I knew that.
And then 1.2 meters divided by 0.74 seconds. I think we're onto something here. 1.2 divided by 0.74. And I get 1.62 meters per second. Okay. So on the table, as soon as the ball hits the table, it's going 1.62 meters per second this whole time. It's going the same speed the whole time.
Yep.
What is the acceleration on the track?
What's that equation for acceleration?
Acceleration equals v final minus v initial over t. Okay, and how long was it on the track for?
1.65 seconds.
So the time for the track is 1.65 seconds. Okay, let's plug that one in. 1.65 seconds. Okay, what is my initial velocity? The ball's hanging out up here. What is the initial velocity going to be? It's sitting still right here, right?
Yep, that's going to be 0.
Yeah, 0 for sure. Okay, how about our final velocity?
Well, what happens to the ball as it goes down the track?
Well, it's gaining speed, right?
Yeah.
And so it's going going slower, getting faster and faster and faster. And then right here, this is a really bad motion diagram.
That's all right. They can't see it.
Okay, and right here, it's reached its max speed.
Can't go any faster.
And then this entire time, it's going to go the same speed, right?
And that speed should be...
We know this speed, don't we?
There you go.
So 1.62 meters per second. Okay, this looks like it's going to be close to 1.
A little bit less.
Yeah, 1.62 divided by 1.65, and I get 0.98. 0.98 meters per second, or meters per second squared.
So how did you do that again?
Okay, so the first thing that I did was I calculated the speed on the table.
Yep.
And I used this equation. I got my answer for that, and then I calculated the acceleration on the track using this speed as my final velocity.
That's important.
Okay.
Maybe have a drum roll, please. Which will hit the ground first?
Which will hit the ground first? Okay. Let's see if I can get this in the first go around. How will you be able to tell which one hits the ground first?
Well, you got a bowling ball and a golf ball. Yeah.
One's gonna go clank, one's gonna go click. So if you listen close enough, can you guys hear that?
It doesn't matter.
Just noticing. If you listen close enough, you'll be able to hear which one hits the ground first.
Yep.
Okay.
There you go.
Hey!
Nailed it.
Which one hit the ground first?
No, I only heard one sound.
If you only heard one sound, that means they must have hit the ground at the same time.
They hit the ground at the same time.
Why is that? Well, they're both starting from the same position,
Yep.
0, and they're going the same amount of displacement, covering
Yep.
the same amount of distance,
Yep.
and they're accelerating at the same rate.
Yep. Takes the same amount of time to hit the ground.
Okay. The force of gravity acting on an object can cause an acceleration.
Yep.
All right, we just said they're accelerating at the same rate. Force of gravity. What? Okay, this is important. The acceleration due to gravity is constant. Gravity equals negative 9.80 meters per second squared, ignoring air resistance.
That's the acceleration due to gravity.
And this negative sign, that's just because it's falling. It's going down. So that's why we have that negative sign there. Okay. Another question. A golf ball is held still, then dropped off a tall bridge. Pretend like I'm on a bridge. How fast is it going after 1.5 seconds?
I think we should do some information mining.
I think we should too. So what do we know just by reading this question? What can we write down?
Golf ball is held still. What does that mean?
Held still. That means the velocity at the beginning is 0.
0.
Right there. So velocity initial is 0 meters per second. What else?
And it dropped off a tall building. How fast is it going?
What are they trying to find out? Our final velocity. But we don't know how fast it's going to the very end. How much time do we have?
1.5 seconds.
Okay, time is 1.5 seconds.
That's not enough.
Okay, well, so we out of all of our equations, we know we need 4 variables, right? And we only have 3. What else could we use here? Working a problem and not enough variables, ask, is it falling? If so, here is your answer. So the difference between these ones and all the other speed ones we've been doing is that it's falling, right? So we have to factor in gravity.
Even though it doesn't tell you.
Even though it doesn't tell you, you have to know. So you could say acceleration, which equals g, which equals negative 9.80 meters per second squared. So whenever you use a or g, it's the same thing. Here it is. Okay, so can we do this now? A ball, same question, right? Can we figure this out?
Yep.
What equation would we use if we were going to solve this right now?
What variable is missing?
We are missing d. We are missing d, so this is what we're missing, which means we will use this equation. V final equals V initial plus a t. All right, hold on to that thought. We will come back to it. Let's talk about acceleration. Before I go any further, we need to understand the direction that acceleration goes. In order to understand the direction, let's talk about the definition. Acceleration is V final minus V initial divided by time. And first, let's look at the math. We know what determines acceleration. My velocities. My time doesn't have a direction. It's always just going to be seconds or
So
minutes.
positive or
whatever.
negative depends on which one's bigger.
Yeah, so let's go ahead and take a look at these guys. Actually, you know what I'm going to do? Oh no, this is good. Let's go ahead and take a look at these. So let's imagine that we are driving a car and we are starting at 0 meters per second and we are speeding up.
What pedal would you be using for that?
Excellent question. We're going to look at 2 examples when we hit the gas pedal. And we're speeding up to 10 meters per second. So if my final velocity was 10 and my initial is 0. 10 minus 0, that gets me a
Positive number.
positive number, right? Okay, so my acceleration should be positive. Okay, so now, again, same things here. 10 meters per second, but this time instead of going this way, we're going the opposite direction. So my velocity is negative here, and I'm going that way, but the velocity, the magnitude, the number is still the same, it's just the direction,
Oh.
right? Okay, so what does this mean for our equation? So negative 10 minus 0, that gets me a negative number.
What does that look like with a car?
Okay, so with a car, so we're speeding up to 10 meters per second, going the positive direction. And here we go. And the acceleration is this way, in the positive direction.
It's positive direction.
Yeah. Now, for the other one, I'm just changing directions here.
Hit the gas pedal and
And which direction is my acceleration?
negative
It's
direction.
negative only because I'm going the negative direction.
So gas pedal gives you an acceleration in the same direction you're going.
Let's write that down. So gas. So it gives you acceleration in the same direction you're going. Some people like words.
I like words. I like money too.
Oh, that's us going. Yikes. Okay, so that's our first example. Now, let's talk about another example.
That other pedal besides the gas pedal.
Yeah, let's talk about the brake pedal. Okay, so for my next trick, we are going to be starting off at 10 meters per second in the positive direction. I wanted to get fancy with it. And I'm slowing down. I'm putting on the brakes.
Yep.
So I'm going this way in the positive direction, and I'm putting on the brakes till I get to 0 meters per second, just like how we did, right?
So the final is now 0 and the original was 10,
So 0 minus 10 is going to get me a negative number.
Oh, okay. Even though you're going in the positive direction.
Yeah, exactly. So we'll take note of that in a second. Okay, so same example. Again, we're starting off at 10 meters per second, but this time we're going in the negative direction, so it's a negative 10 meters per second, and we're braking still. Should look like this. Okay, so 0 minus a negative number, that's going to give me a
Positive number.
Should we demo with the car?
So the acceleration is positive when you put the brake on in the negative direction.
Yeah, so
Let's see the car.
This gives you an acceleration in the opposite direction that you're going. So for our first example, we're going 10 meters per second this way, and we're slowing down. And now the acceleration is that way.
Oh yeah.
Okay, flip it around this way. We're going this way, moving at 10 meters per second. Now all of a sudden we're slowing down.
So it doesn't matter what direction. When you put on the brake, the acceleration is the opposite direction that you're going.
I'm going to write this down. So acceleration equals opposite direction that you're going.
When you put the brake on. And it doesn't matter if it's positive, negative, up or down.
Now, if you're confused right now, that's okay. It is normal to be confused with physics at first.
Well, especially acceleration. Acceleration is confusing.
Yeah, acceleration it's strange. We're not used to it. And so hang in there, okay? Let's go into our next thing. Now that we've talked a little bit about acceleration, a team effort here. Okay, what happens when you throw something straight into the air?
Do that again. Do that again. Higher. Sweet.
What's happening here? It slows down on the way up, right? And it comes to a stop at the top,
Here,
right?
do that again.
It's slowing down on the way up.
You're better than me. I don't catch it all the time.
What would be the direction of the acceleration?
Oh, on the way up, it's slowing down. Is that gas pedal or brake pedal?
It's brake pedal, so it's going to be opposite, right? So if it's going if it's slowing down but going this direction, it's going to be opposite. That means that our acceleration is
Down.
down. Okay. Okay. Oh, what's happening on the way down? So it's slowing down on the way up, and the way down it's
Speeds up.
yeah, it's speeding up on the way down. So it speeds up on the way down. That's kind of like hitting the gas pedal. What would be the direction of the acceleration?
Gas pedal's the same direction.
Same direction. So the acceleration would be down.
That means on the way up, where it's slowing down, the acceleration is down. And on the way down, where it's speeding up, the acceleration is still down.
So it's always down.
Yeah.
Okay. This is starting to make a little sense, more sense, I think. What happens to its motion at the very top? This is pretty important. At the very top, right there. Right there. It's zero. It's stopping the fluid, right? Should we take a look at page 105?
I think we should.
Let's do it. Okay. Let's take a look at these two graphs. Ignore these ones. And we'll start here. What kind of graph is this?
X versus T. That's position versus time graph.
It's a position versus time. And this is actually a position versus time graph of a ball being thrown in the air.
Yeah.
Okay, so what happens is it's thrown in the air, and, well, the slope of the line is our velocity, right?
Yeah.
And we can see that right here it's going really fast. Right here it's going a little slower, a little slower, a little slower. And at the top, our slope of velocity is 0, which means it's not even moving, right?
At the top.
Yeah, it's slowing down.
And then
And then,
it starts falling.
Falling, it's speeding, faster, fall. Oh,
But it's in the negative direction.
it's in the negative direction. Okay. And how would you know it was the negative direction? Well, our displacement is negative, so our velocity is negative. And so it's right?
That's right.
Yeah, okay. Okay, so that was position versus time. What does this look like on a velocity versus time graph? Way different, right? Okay, so what is this? What do we have going on here? Well, we've got time and we've got velocity over here. And what happens is as we throw the ball up in the air, I'm actually going to turn it sideways.
I like that.
As we throw the ball up in the air, the velocity is getting slower, right? Closer to 0.
Starts off at 20.
Starts out
20.
fast, yeah, positive 20, getting slower. Oh, this must be the top because the velocity's at 0.
Yep.
And then it starts going faster again, but this time it's going in the negative
It's going down.
direction. It's going down, right? So it's still going 20 meters per second, but just going down. That's what that negative sign means.
So what does the slope of a line on a velocity versus time graph tell us?
It tells us the acceleration.
She's right, you know.
So what kind of acceleration do we have here? Is it constant?
It's constant. and
Definitely constant.
Downward slope, so that's a negative acceleration.
Yeah, okay. Good work, guys. Good teamwork there. If a problem involves something falling or being thrown straight up, use G as the acceleration. Yes, do it, people.
And what is G anyway?
Negative 9.8 meters per second squared.
Wait a minute.
Oh, this question again.
We never finished this.
The golf ball is held still, then dropped on a tall bridge. How fast is it going after 1.5 seconds? Shall I do it with them or is it homework?
Well, we can show them.
We should do it with them.
We'll give them other things to do.
Okay, so this is my equation. I've got all the variables. I'm using G as because it's falling.
You could turn that A into G, couldn't you?
I totally could. This could be a G like that. Okay, so my initial velocity is, 0. Goodbye. Okay, my gravity is negative 9.80 meters per second squared times the time, which is 1.5 seconds. Okay, negative.
Maybe about 14 something.
Negative 9.8 times 1.5, and I get negative 14. That is nice. Negative 14.7. What are my units here? Velocity? Seconds, meters per second.
What does it mean if the velocity is negative?
It means this has to do with the direction It just means that it's going in the negative direction. Or
Having
falling.
falling
right?
can be a negative experience.
Oh, that's good.
Oh yeah,
Start using
said that a few times.
Okay, I think. Oh, how far will the same ball fall? Oh, great question. Okay, so now we're trying to figure out the displacement, right?
Yeah.
Okay. So, what variables do we have here?
I think we've got all of them. We get to choose.
We've got all of them. Now, there's a chance that we might have messed up on this calculation, right?
Yeah.
So we could pretend like we don't have this one and use that one.
Yeah, I like that one, especially when the original velocity is 0.
Yeah, okay, so let's go ahead and use that. Oh my gosh. Okay, so D equals, okay, that plus 1/2 AT squared, and this is 0, so we just ignore it.
Ba-boom!
Ooh, yeah. So 1/2, my acceleration is negative 9.80 meters per second squared. And my time, 1.5 squared seconds. Okay, let's do this. So 0.5 times negative 9.8 times 1.5 squared, and I get negative 11.0. We're talking about displacement, right?
And the
These
second
cancel these
squared, and you got meters. What does the negative mean, Miss Moore?
Well, the negative just means that we're going in the negative direction.
That's
Which
right.
means, which is correct because we're falling, right?
That's a negative experience if you ask me.
Okay. All right, that's how you do it, folks.
Is that it?
Oh, we're done. Woohoo!